Today we are going to be learning about sequences, and a sequence is just a list of numbers. The domain is the set of positive integers. So when we talk about a sequence of numbers, my first term I'm going to call a sub 1, a sub 2, a sub 3, etc. The first couple things I want to be able to do is write out the terms in my sequence. So if this is your general formula for a sequence where n is a positive integer, then in order to find the first four terms, a sub 1, I'm going to plug in 1 for n, that will give me 3. A sub 2, I'm going to plug in 2 for n, which will give me 5. And the pattern continues, and these are my first four terms, 3, 5, 3, 5, etc. I can also go ahead and find the first four terms of this one. If you want to use a calculator to create a list, that would be fine as well, but your first four terms should be this. At this point, I would pause the video and try to create the first four terms of number 3 on your own. Okay, checking your values, you should get 0, 1, 1.1429, comma 1. These are explicit sequences. There is something called a recursive sequence, and that is when your next term depends on the previous term. So notice here, I'm giving you the first term, which is 25. This is how you create the next term. So in order to get to a sub 2, I will take the first term, the previous term, a sub 1, and minus 5. So a sub 2 is going to be 25 minus 5, which is 20. So a sub 2 is 20, and then the pattern says take the previous term and always subtract 5. So a sub 3 is 15, and a sub 4 is 10. Okay. This should be mostly pre-calc review. What we are most interested in calculus is seeing if a sequence or a list of numbers converges to a number. What that means is the limit of that general term as n goes to infinity, does it approach a value? If it does, we say that the sequence converges to that number, otherwise we say it diverges. Please make a note card on this box and call it sequences. So the next example, the question is, does this sequence converge or diverge? There are a couple ways you can do it. One way you can do it is you can start listing some of the numbers and see if you'll see a pattern. If I go ahead and list the first couple terms, you will notice that this sequence just alternates between 4, 6, 4, 6, etc. So this sequence never converges to one number. It always oscillates between 4 and 6. So I would say that this sequence diverges. Another way to determine whether a sequence converges or diverges, and the most common way, is you can try to take the limit of that general term. The limit of this general term ends up being negative 1/3. So if you list out these numbers, or if you look at a table, you will notice that this sequence converges to that value of negative 1/3. So let's take a look at these four examples and see if the sequence converges or not. At this point, I would pause the video and try to do the four problems on your own, and then come back and check your answers. Okay, the first problem, it does not give you a general term, but my general term is 1 over 2 to the n. All you're doing is raising the bottom number to the 2 to the nth power. So this is my general term. So if I take the limit of the general term, that limit is 0. So I would say that this sequence converges to 0. B, I am given a general term, so I'm going to go ahead and take this limit. This limit may not be something that you know intuitively, but this is from chapter 6. This is the definition of the number e. You should have a note card on this from chapter 6. So this limit is e. So because this approaches a number, we say that it converges to e. Okay. C, if I take this limit, this also converges to negative 1/2. And lastly, D, this limit, you can do L'Hopital's rule on this if you want, but notice that you have an exponential on the bottom. Exponential always grows quicker, so I would say this limit is 0, so this converges as well. So in order to determine whether a sequence converges or diverges, one way is take the limit of the general term. If it gets to any numerical value, it converges. If it goes to infinity or oscillates between two values, you can say it diverges. Okay, next, a little review from pre-calc on factorials. We'll be working with factorials a lot this chapter. 0 factorial is defined as 1. 1 factorial is defined as 1. 4 factorial is 4 times 3 times 2 times 1, which is 24. 20 factorial over 19 factorial. You can list out all of these factors, but what you should notice is all of the factors on the top and the bottom from 19 on cancel, so I'm left with 20. 10 factorial over 8 factorial is really 10 times 9, which is 90. N factorial over n minus 1 factorial. The first factor on the top is n, the second one is n minus 1, reduce the power by 1s, etc. And then on the bottom, notice then you have the same factors on the top and the bottom, so you are left with n as that simplified version. Okay. Next, given a sequence, can you find the nth term? So we're going to start at n equals 1. So notice on the top, these are just powers of 2. So the first number is really 2 to the first. This is 2 squared, 2 to the third, etc. So the top of the fraction can be written as 2 to the nth. Notice the bottom goes 1, 3, 5, 7, 9. This is a common pattern that you will see. This can be expressed as 2n minus 1. The second one, again, your n should always start at 1. The top is always 1, so this is our general term. The bottom, notice our powers of 2, so this is 2 to the n. So our general term is a sub n equals 1 over 2 to the n. Okay. The last thing I want to talk about is what's called a monotonic sequence. This is a vocab word. And a monotonic sequence is a sequence if the terms are non-decreasing or non-increasing. All that means is the values are staying the same or always going up, or the values are staying the same or always going down. So this would be considered a monotonic sequence. This would be considered a monotonic sequence.